Good afternoon, everyone. Today we are going to start a new chapter in your book, transfer function. The next chapter you have it in your book. This chapter combined in two lectures. It is actually based on two different topics: transfer function and block diagram. Two topics. Today we talk about transfer function. In the next lecture we talk about the block diagrams. So the transfer function, I already talked about the transfer function in a bit before in our previous lecture in the mathematical modeling. Few basics. Today our whole lecture is based on this topic, transfer function. So what is the transfer function? If we draw a system, a simple system where an input is xt and the output is yt, and here inside we have a system. In time domain, this system calls it impulse response. Impulse response. How the system responds for an input or for different types of input. How a system responds. Impulse response is the response of this system. How the system will behave for this input. We will get an output based on that. Now, this is in time domain. I already told you that time domain is not much more beneficial to analysis. So, what we need to do, we need to convert it in other domain, in frequency domain. In frequency domain, we can convert it by using Fourier transformation, Laplace transformation. So, here we will talk about the transfer function. So, while the system will be converted into by using a Laplace transformation, Laplace. While the system will be, and this impulse response, we mostly define it by ht. ht. This one. This is ht. In time domain. Now, what will happen after the Laplace transformation? This time domain will be converted into frequency domain, that is in S domain. So, this ht will be converted into hs. The input will be converted into xs. And the output will be converted into ys. Now we have this system. This system we call it a transfer function. This is called transfer function. While you convert a system from time domain to the Laplace domain by using Laplace transformation, then the impulse response that we had before for the system, we call that is a transfer function. So what is a transfer function? Mathematically, it is a Laplace transform of output and the Laplace transform of input. The transfer function is the Laplace transform of output, the ratio of the output Laplace transform and the output of the input Laplace transform. So we can write it as this ys by xs. So mathematically you can say it is an input-output relationship. It is a mathematical representation of input-output relationship for a system. And what does it mean? It means that how the system behaves, this system behaves for different types of input. So for the different types of input, we will talk about different types of input today. Many inputs we have. So we will talk about the many different types of inputs. So how the system will behave for the different types of inputs, we will get a corresponding output based on that. So L, here this L, it is mentioned in small letter. You can use this one or this one, both are the same. Laplace transform. These are the Laplace operator. While you convert a time domain, you will use the Laplace transformation Laplace operator. It will be converted into S domain, frequency domain. But now here you must need to know one more thing. It is considering all the initial conditions to 0. Initial condition. What is this initial condition? Initial condition is very important. We always consider this initial condition 0 to make our calculations simplified. Initial conditions means while t is equal to 0. Initial condition. Initially, at the beginning, t is equal to 0. That is what we call the initial condition. So we always consider this initial condition at t equal to 0. The value is 0. This value ut, it will be 0. Because at the beginning there is no input before. So when it starts t equal to 1, 2, 3, 4, there will be an input. But before, at the time t equal to 0, there is no input. So we always consider that is 0. So that is what initial condition is 0. Now Laplace the transfer function, we can write it in this format: GS. GS, HS are the same. This one I wrote it in HS. You can write it in GS. So you can write it as GS or you can write it in HS. Anything, it's okay, it's fine. So this is mostly we call it the DF, the transfer function. Transfer function will be output by input. Now, why we need to use the Laplace transformation? Laplace transformation mostly it's beneficial because it can convert any complex function into some algebraic sum. Algebraic sum. What is this algebraic sum? Algebraic sum is this. Algebraic function means this a plus b, a minus b. These are the algebraic functions. Addition, subtraction. These are the algebraic functions. Now, any complex function. Suppose here sine omega t. What is this? This is this. This is the sine wave. Cos omega t. These are called the common functions, many common functions, sinusoidal functions, complex functions. These are the sinusoidal functions. This sinusoidal function can be converted into, in this format, algebraic format, by using Laplace transformation. So if I use the Laplace transformation of sine omega t, we get this omega by s square plus omega square. There are proofs. We cannot prove because this is not the math proofs. We can prove it that how we get the sine omega equal to omega by s square omega square t. So Laplace transform of cos omega t. This is gives you the value of s by s square plus omega square. Any common function you can convert it in algebraic function. Algebraic function, addition, subtraction, anything. So what is s? S. What is this? S is this. This is called S plane. This is S plane. Where this is real part. This is imaginary part. Real part we call it sigma, and this one we call it j omega. So this S is equal to sigma plus j omega. Explain. S is a complex function. This is equal to sigma plus j omega, real and imaginary part. So that plane we call it S plane. So at the y-axis this is imaginary, but in the x-axis it is the real part. This one also you can write it in this way. S is equal to a plus jb. Same. A plus jb. This is also the same. Sigma and j omega, mostly we use it in control system. Sigma and omega. So these are the same thing. S is a complex variable. So there are different types of inputs. I already told you that transfer function is the function that will evaluate how the system behaves for different types of input. This xt, if xt is different, suppose if xt is delta t, what is delta t? Delta t we call it impulse function. Delta t we call it impulse function. And how we draw it? This is an impulse, delta t. Delta t is equal to 1. 1 means here, only this only one value. Impulse, what is impulse? Just one pulse, fluctuating, just one. Very briefly, here, there is one pulse only. And here, 0, everywhere 0, less than and greater than, everywhere 0. T, this is T, this is T is less than 0, and T is greater than 0. So all the values are 0. Only the function at t equal to 0, there we have the value of delta t. Now that is the impulse function. So this function, if we have here xt is delta t, then we can find out the function. But before we need to convert it in Laplace domain, then we need to convert this xt to xs, and if we convert this xt to xs, then we will have only one. This is the mostly we use. So we usually don't write this one because 1 multiplied by anything is 1. So for the delta t it's fine. But what about the ut? Ut we call it unit step. Unit step, same step, equal step, like this. This is called unit step. All the step size are same. That's why it is called unit step function. So shortly we write it this like this. Here like this. This is ut. This is ut. So suppose here this xt, now if it is ut, then how the system will behave, we can explain, we can find out. But first we need to convert this ut into Laplace domain, and if we convert that, we will get it in 1 by s. Now it is not 1 by s. So for the different input, the Laplace transform will be different. Suppose third function, this is the key. What is t? Just straighten. This is t, right? This is just y equal and x. Here m is equal to 1. So it is just x. Here it is t. So this one we can write it y equal to t. Now this function, if you have here, then it will be converted into 1 by s squared. The Laplace transform of this t is 1 by s squared. The fourth function, t squared. What is this t squared? This is t. So this is t squared. What is this? This is t squared. T squared function. Another input. So if this you have, then the Laplace transform will be 2 by s cubed. It will goes on. And here suppose we have E inverse alpha t. This alpha t minus, we have a plus. If we have plus sign, we have a minus. This is s plus alpha, s minus alpha. And here for the sine and cos, we already showed you for the sine and cos. For the sine is omega by s squared plus omega squared, cos s by s squared plus omega squared. So you see, these are many different functions, various functions, many functions. It is not the same, many different inputs. This is the E inverse AT. What is this? This is this. And E power AT. This is this. This is cos. This is sine. Many functions. You can convert all the functions in Laplace by using Laplace transform, and you will see, you see only here s plus alpha, s minus alpha, s squared plus omega squared, s squared minus omega squared, like that. Everything. That's why we use the Laplace transform to convert all the periodic function, all the common functions into Laplace domain, so that it will be in a very common algebraic function. So you don't need to remember all. These are very important. Remember this one. E inverse it is sine, cosine, and sine. These are the common function we use. Yes, you try to remember all these functions. Not all. Here there are many different inputs can happen. Suppose here we have two functions are multiplied, E inverse AD and sine omega d. It is conjugate, multiplied and you can get another function. So there will be different types of inputs like that as well. So any input will be converted into Laplace domain, and then whatever the output will be, we can observe it by finding this transfer function, the ratio of the output and input. We find out the output and input ratio, then we find out the transfer function. So that's why we call the transfer function is the ratio of the Laplace transform of output and Laplace transform of input, which will give you the input-output behavior of the system. Now, these are the common functions which I told you. Also, there are some other functions can be converted, like derivatives. Like as here we have some derivatives. ddt. What ddt is the rate of change. ddt, dx, dy, dt. We have seen that in our previous lecture. Again, we will talk about this in some more details. Like here we have derivatives dx, dt. Shortly, we call this as x dot t. X dot t. So if we use the Laplace transform of this, if we use the Laplace transform for this, so what will be the value? It will have s xs minus x0 as xx minus x0. What is this x0? This is called called initial condition. Initial condition. How? Here, look at this value. This is 0. For what? This is the function of t. That means what? Here t equal to 0. T is equal to 0. At the time t equal to 0, what is the value of x? Here, look at the function. Look at the function here. At the time t equal to 0, what is the value of x? 0. X0 is 0. Because when there is no time, when the circuit is not started, you did not provide any input. That means what? Input is 0. While you are not providing any input at the time t equal to 0, so at the time x will be 0 as well. So when you will give the input, so at that time t will start 1, 2, 3, 4, 5, 6 like that. At the time while you provide the input. Before that t equal to 0, at the time x equal to 0. That's why we consider this initial condition is 0. But it is not practically it does not applicable. Mathematically we consider this mathematically. Second one, so here what we can write? We can write it as just like this, as xs, only this, because this value is simply 0. We are considering initial condition 0. Now Laplace transform of second derivatives dx squared xt dt squared. So this one, we also can write a Laplace transform of x double dot t double dot. Shortly we write that. So here we will have s. Now we will have s squared xs minus s x0 minus x prime 0. So there will be only one term that will have s, and all the term will have 0. And we already know the initial condition. We are considering this will be 0, this will be 0. So we will just have this s squared x. Third one, like Laplace transform of third derivatives d squared x d cube. Third derivatives xt dt cube. Shortly we can write that x triple dot t. So here we will have s cube xs minus s squared x0 minus s x prime 0 minus x double prime 0. So all the values will have 0. All the value is just initial condition. So all the values here, all the values 0, 0, 0. So we will just have that s cube x s. So these derivatives we converted it in as domain by using the Laplace transformation. So mostly you need to remember 3. X double dot, x triple dot. Sometimes you need this in your final exam. There will be some questions. So try to remember this. So altogether, what we can write altogether, if we have n order, if we have an order of n, n order. So what do we have? We will have term power of n is n, and the xs, and all these values will have 0. All the values will have 0, initial condition of 0. So this will be just like s and xs simply. Okay, now we will talk about one example for the RC circuit. RC circuit means there will be one R and C, no L, no inductor. Now, how here V is an input voltage, we have an input voltage V, and Y is the capacitor output. We have a V, that is input voltage, there is R, this is C. So corresponding voltage we can write it VR, corresponding capacitor voltage we write it VC. Now we can write it in this way, because these are the two grounds. So two grounds we can connect it and we can make common ground. And now what is this? This is a closed circuit. While it is a closed circuit, we apply current. There will be a current. There is a current. And we can apply a rule that is called KVL. For a closed circuit, we can use a KVL. What is KVL? Anyone remember? What is KVL? Kirchhoff's voltage law. So what is this? If you forget, all the voltages addition of all voltage drops in a closed circuit is 0. R 0. So addition of all the voltage drops in a closed circuit. This is a closed circuit, and we need to find out the voltage drop. How many voltage drop? 1, 2, 3. 3 voltage drops in a closed circuit are 0. So how we can write that? Minus V plus VR plus VC is equal to 0. So we can write it V equal to VR plus VC. Now what is VR and VC? What is VR and VC? VR is equal to IR. And what is VC? 1 by C integration of I dt. We already know that VC, capacitor voltage, VC is equal to 1 by C integration of I dt. And VR is equal to IR. So we apply this. Now what we need? We need to convert it in S domain, because it is in time domain. In time domain we cannot use this. Now we have a term, this term. Integration of I dt. How we can convert this? Here. We can convert this through the integration. Integration property also can be converted through by a Laplace domain. So if we convert an integration property through the Laplace domain, integration of x dt, xt dt. So integration, this operator can be converted into S domain by using Laplace transform. So here the S is multiplied, here the S will be divided, and we will get this 1 by S xs. And there is initial condition. There is initial condition. Has to be initial condition. We consider that as 0. There is an initial condition, same like that, but it will be 0. Now we see that here in this circuit. In this circuit, this is switch. this switch is closed at t equal to 0. Before it was open. While it is open, no voltages, no current flow. At t equal to 0, it is closed. Closed at t equal to 0. So it is closed. Now there will be a current flow. Before it was open. So initial condition is 0. Now we have this, and now here we need to consider an input. Here the input is ut, not 1. ut, what is this ut? Unit step. Unit step. I told you this is ut. This is ut. Ut. And Laplace transform of ut is what? 1 by s. Here. Here. Laplace transform of ut is 1 by s. Before we consider all the functions, we consider that is delta t 1. So we didn't write it. Now we are changing our input. We are considering that input is ut. You can consider t. You can consider t square. Any input you can consider. We are just considering this ut. So we can write this function as like this. Same thing. We have 3 voltage drop. 3 voltage drop. So this is VR, this is VC, and here we have VUT. Because the input we are considering that is UT. So you write the VR equal to IR plus 1 by C integration of I dt. Now convert this in Laplace transform. Laplace. So if you convert it in Laplace transform, there is a B, and ut, Laplace of ut is 1 by s. 1 by s. And it will be converted into is. R is fixed. 1 by c. It is fixed. And this term, integration term, we will have 1 by s xs. So this one will be integration of I dt here. This is the Laplace transform of that. We will have 1 by s is. Now I say we need to write down the initial condition. There is an initial condition x0. Here, what is the initial condition? Initial condition is q0. What is q? What is this q? Q is charge. Charge of this capacitor. Charge of this capacitor. Capacitor, what it does? It charge and discharge. Capacitor only do 2 things. It will charge while there is an input. It will discharge while there is no input. Like your battery, your smartphone battery. You connect your battery, there will be charge. It will charge. You disconnect your battery, it will discharge. So charging, that you are connecting your smartphone with an input, with the power cable. Here it will charge. Now, before you connecting any input, initially we are considering that there is no charge. That's why it is Q0, Q0 minus. So this value will be 0. Initially this value will be 0. At the time t equal to 0, that value will be 0. So total value will be 0. So we will have only this 1 by C into 1 by S. So we can write 1 by Cs into Is. So here we have this term and this term. So we will take this common, and this B by S equal to Is into R plus 1 by Cs. Now I need to write down this V by R. So here we have an IS value. IS is equal to 1 by here this is here is B, and we have S R plus 1 by CS. So V into, we can write it here. What we can write, we can simplify it by using this. We divided by R, S divided by R, and R plus 1 by CS. There is 1 by R in numerator and denominator, so it will be gone. It is fine. So what we can write, V by R is equal to, here we have R and R, it will be gone. So here we have S plus, here we have, it will multiply RC. S will be gone. So we have RC. So IS is equal to V by R S plus RC. Now here you see we have a term. This term is plus RC. So look at this. Go back. S plus RC. This is nothing but an exponential function. Exponential. So if you want to convert this in time domain again, so you will get an exponential function. Your output is exponential. Now look. First, which input you provided? You provided an UT. You gave an UT input here. You gave an UT input, and finally, what you got? You got an exponential function. That is what you will. A transfer function will give you the information. The information. You provided input. Which input? This is UT function input you gave. But the output that you got, what is that? That is an exponential function. Here, S plus RC, S plus RC. When you convert it in time domain again, when you convert it in inverse Laplace transform, by using inverse Laplace transform, you convert it in time domain again, you will get an exponential function. So this is the relationship between input and output. That's what the transfer function gives you, the information it gives. So this is why we need to find out the transfer function in Laplace domain. Okay, so in the Laplace transformation, there are three important properties that are very important. There are many properties, but these are the three important properties. First property is linearity property. Linearity property, that is individual Laplace transform, addition of individual Laplace transform, is equal to combination of the whole Laplace transform. Combination of all signals Laplace transform. Like here, what is that? Here we have, this is the Laplace transform of F1t plus F2t. F1t and F2t combined signal is equal to Laplace transform of individual signal. In the Laplace transform of individual signal. Individual signal is equal to the Laplace transform of combined signal. We can prove that, but here we just look at this. We can prove this very easily. Second one, the derivatives. In the derivatives, we have the differentiation df d by dt. We can have sfx, and initial condition f0 is 0. Third, the integration property, we have 1 by sfs plus f0, which is 0. So three properties are very important: linearity property, differential property, and integral property. three different properties are very important. Remember these three properties. You always need to use these three properties over there whenever you do the Laplace transformation. Okay, now let's talk about one more example. We are talking about an ODE. ODE mostly we call it a differential equation. ODE called ordinary differential equation. This ODE, this means ordinary differential equation. Ordinary differential equation. Now here what we need to see, what is given, yt is given as input. Yt is given as input and xt is the output. It is not now xt is the input and yt is the output. Now the equation is given. The system is given in this way. Yt is the input and xt is the output. Xt is the output. So if you convert this in Laplace transform, you will get a function like this: ys by xs, and here we have the hs. This is ht. So what is hs now? What is hs now? Tell me, anyone? What is the hs for this? The input is ys, output is xs. What is the hs now? What is hs? Output by input. Output by input. What is output? This is output, right? And this is the input now. So this will be xs by ys. Because our question tells us that yt is input, xt is the output. So read the question before you answer. Read the question. It can be anything. Before we have seen that xt was the input and yt was output. Now yt is the input and xt is the output. So our equation will change. Our equation will change according to that. System will change according to that, according to our question. So here our question tells us yt is the input and xt is the output. So our transfer function will be xs by ys. Remember that. Okay, I will explain that after the break. Let me call your name.